Hello people, welcome to today's tutorial. Today I will teach you how to simulate airflow over an aerofoil. First of all, you need the profile of the aerofoil, and for that you need to go to this website here. I will leave the link in the description. And you can choose any of these aerofoils, and then they will give you the coordinate points in the form of a DAT file over here. I have already extracted these coordinates into a .txt file in Notepad. So as you can see, I have copied the coordinates into this notepad file. So now we're going to make the aerofoil. Those of you who are not interested in viewing this part can fast forward to a time which I'm going to leave in the annotations. So now let's get to designing it. So select the curves section and then select curve through XYZ points and then browse. Then input the .txt file that you had created earlier. So see, it has already generated the shape. Now click OK. OK. Now every design software has some perks, so does SolidWorks, and we're going to deal with that now. We're kind of going to have to repeat this process all over again, but it doesn't take much time, so let's just go ahead with it. So we're going to sketch on the front plane. Now click on this and then convert entities. The entity has been converted, as you can see by the black lines. Okay, exit sketch and then delete the original curve. Do not delete the dependent items. Okay, now there is an error here, but not to be worried with that. Just click edit sketch, double click on this brown box here and delete this relation which says on edge. Okay, we're all set to go. Now I want to change the angle of attack of my aerofoil, so I'm going to bend it a little. Just click over here in the command section, write rotate, entities to rotate will be the spline 2, and center of rotation. Center of rotation should be any point other than this point. It can be any other point other than that point. Okay, now I'm going to go with -4 degrees. Okay, how about, let's just go with a higher pitch. Let's go, how about -20 degrees. Okay. So now we're done with it and we'll exit the sketch. Okay. Now we need to create a negative of the part that we're going to simulate in Ansys Fluent. So let's create the negative. We'll go back to the sketch and we'll draw a fairly large rectangle around the aerofoil. Just remember to have the downstream side longer than the upstream side. That is the only parameter you need to be concerned with over here. Now go to the surface creating options known as planar surface, and see, by clicking on planar surface, it has generated a surface, leaving a hole in the shape of an aerofoil in the middle. As I said earlier, we're going to create the negative of the desired shape in Fluent. Okay, so now that we've created it, we'll save it. I will name it Aerofoil T. Okay, it's been saved. Now we can close SolidWorks and go to Workbench. So let's double click on Geometry. Okay, Design Modeler has opened. Now we're going to import the file. So go to File, Import External Geometry, and it was named Aerofoil T. So we chose Aerofoil T. Okay, now right click here, generate. Okay, it's loaded. Now we don't actually have to do much over here. Let's just move on. Save the project. Okay, I'm going to name it Aero T. Now we move on to the meshing section. Okay, so now we need to see how it meshes. So let's just right click on mesh and then generate mesh. It's taking some time because, you know, at the same time the screen is Camtasia and Fluent are simultaneously running. So as you can see, this meshing is not very good. It's not uniform, and we want the level of detail to be higher around the boundary of the aerofoil, and it's kind of non-uniform and it doesn't look good. So that's bad for calculation, and so we're going to fiddle around with it a little right now. So first, right click here and then insert method. Okay, so select the geometry, double click on the yellow geometry thing, and then click on this surface and then apply, and then method, single click on quadrilateral dominant. You will see this drop down arrow, click the drop down, choose triangles. Okay, then right click and then mesh. Okay, now see, it's somewhat better than what it used to be, but still, as you can see, the resolution is high near the leading edge and the trailing edge, but in between it's not so good. So we want that to be uniform. Okay, we want the resolution to be high and we want it to persist uniformly around the boundary. So we have to tinker around with it a little more. So now we're going to do edge sizing. So select the geometry, which is going to be the surface, apply, then sorry, double click on scoping method. Okay, double click on scope, yeah, geometry selection, then select this over here, which is called edge selection. Select this and then select the edge, and there you go, you have it. Element size, what's going to be the element size? How about, let's just say, so click on element size, and here's what I'm going to do. So 0.01. okay, and now I'm going to generate. So as you can see, it's uniform around the entire boundary, but I don't want it to persist to this very small range. See, it's dark just near right around the edges, and this high resolution does not persist, and it fades away the farther away we go from the edge. I don't want that. I want it to be persistent up to a certain number of layers. So I'm going to insert another thing, another option here, which we call inflation. So first select the geometry. Okay, next select the boundary, double click on this boundary, and then select the edge. Okay, apply. Now inflation option, we're going to choose first layer thickness. We're going to assign the thickness of the first layer. It's going to be 0.01. Maximum layers, I'd like to have 40 layers, and let's just up the growth rate to 2.5. okay, and we're going to generate mesh. Let's see what happens. Okay, not much change right there. So we have changed the maximum layers to 10, and we have generated the mesh, and this is the result. See, so this is what this was my desired state that I wanted in the beginning, and now I have it. But can you notice the non-uniform nature of these mesh zones? See, it's really well defined here, high resolution here, but not so much outside. I want the outside regions to be uniform with this, so I'm just going to click on this mesh. Okay, then I'm going to click on sizing, and then I'm going to change these two parameters, max face size and max size, and I'm going to make them equal at 0.0. How about this? How about say 0.1? I don't want them to be as well defined as the immediate boundary layer, because quite frankly it's just a wastage of computational power. Okay, now let's generate the mesh. So as you can see, it's a little more well defined than it was before. Not a little more, a lot more actually. See? Okay. So let's carry out the simulation right now, and one most important thing you have to remember is we will name our surfaces in the meshing section. Don't forget to do this. All the naming, all the creation of name selections will be done in the meshing region. So I want this to be my inlet. I'm going to create a name selection. This is going to be the inlet. This over here is going to be the outlet, and the wall on the top and the wall on the bottom, these are going to be specified shear walls. So I control clicked both of them, and I'm going to name them SP shear wall. Okay, SP shear wall. Okay, so I've created the name selections over here, inlet, outlet, SP shear wall, and I also like to create another name selection around the aerofoil. So I click on the edge and create name selection. I'm going to call this aerofoil. Now be careful, you must have this selected from before in order to select edges. So this is the edge selection. Have this selected from before in order to name name your planes or name your edges. Okay, so we're done with the meshing part. So save and move on. Double precision as usual, parallel. I have 4 cores and 1 GPU. Let's move on. Okay, so now we have opened setup. Okay, so we double clicked on setup, we got that double precision and parallel processing option, and then this opened up, and now we're going to specify our problems, apply the conditions. So in general there's nothing to be done. Oh yeah, there is something to be done. This is going to be a transient state problem. That is, we will not reach any solution after a definite interval of time. It will just be just keep repeating itself on, and the accuracy will depend upon how many cycles we complete. So we'll never reach never converge. Okay, materials, fluid is air. Cell zone conditions, nothing needs to be specified here. Double click on inlet, go to boundary conditions, double click on inlet, assign a velocity. I'll go with a fairly high velocity, say 120 meters per second, and then SP shear outlet, don't need to modify that. SP shear wall is going to be a specified shear wall. So okay, and solution methods. Okay, now since we selected transient over here, it's better to go with second order implicit. Okay, solution controls, I mean, you don't need to fiddle around with this. Monitors, you could apply a lift and drag coefficient. Some other guy shows you in some other tutorial. I'll just leave the annotation here. I'm not going to show you. Solution initialization. Okay, so it's a rule of thumb that if you're doing a transient problem, then choose hybrid. Okay, so choose hybrid and initialize. Okay, initialization is done. Go to calculation activities. Now autosave every one time step if you want to generate the movie file, and run calculation. Okay, it's going to be 0.01 seconds. Number of time steps is going to be 200. No, I'll keep it low. I'll keep it 150, and the max iterations per time step is going to be 200. Yeah, it's going to be 20. So we are going to have a total of 3,000 iterations, and let's go ahead and calculate. So as you can see, this is sawtooth graph. This actually basically shows you the errors. As you can see, the errors they're going higher and higher actually sometimes, and then coming down lower. So that's the nature of the transient problem right here. They won't converge. They'll just keep on going like this. You're going to have a continuous sawtooth diagram. So just the idea here is to go on long enough. Okay, you're not going to get an exact solution. So this is not a steady state problem. So see you on the other side, guys. Okay, we're back, and calculation is complete. So let's close this and let's go back to Workbench and double click on results. So here we are in results. Now we first want to see the streamlines. So click on streamlines and start from the inlet, and let's just go high. Let's go with 100 streamlines. And the variable is velocity, and let's just apply. Let's see what happens. So see, we get the streamline, and here you have the flow separation over here. So now we want to view it as a contour. So let's just do the contour. Not pressure, variable is not pressure. We want stationary frame U. Select that. Location will be symmetry 1. My experience 50 is the best. Okay, let's see. So there you go. Now if the color seems a little too much, advanced properties, drop down, change it to Fluent Rainbow. Yeah, that's easier on the eyes. Yeah, this is much better. Now if you want to do an animation, just click on time steps and deselect infinite loop and play. So there you go, people, you have it. Now you can play around in post-processing, change the animation quality, save it as a movie file. So good luck guys, I'm ending it here.